In this video, I want to talk about cumulative probability functions. You have actually met this idea before. You met it in S1 when you were dealing with the normal distribution. With the normal distribution, you used your tables and you discovered that the area up to x equals 0.5 is, and from the tables, this is 0.6915. This meant that the probability that x is less than or equal to 0.5 is 0.6915. In other words, the cumulative probability, the probability right from the lowest value up to x, lowest value up to 0.5 is 0.695. That is what we mean by the cumulative probability, the probability right from the start up to whatever value we're considering. Now, this idea doesn't just work for a normal distribution. This works for anything which satisfies the condition for a probability density function. We have exactly the same sort of picture here. The probability now that x is less than 2.5 or less than or equal to, makes no difference, is the cumulative probability. And it is just the area shaded. This would mean that it was equal to the integral from 1 to 2.5 of whatever the equation is, 0.75 x minus 1, 3 minus x dx. So that is your connection between the probability density function, which is the curve, there it is, and the cumulative function. And we write that always with a capital F. You must be careful now to distinguish in the way that you write your letter F. Write a capital F, you mean the cumulative probability. If you write a small f, you mean the probability density function. Now let's look at the connection between big F of x and little f of x. As we've just mentioned, the cumulative probability function, which is big F of x, is the area under the probability density function from whatever the lowest value of x is up to the value we're interested in. So let's have a look at an example. Let's suppose that f of x, little f of x, that is the same one as I had just now, is 3/4 x minus 1, 3 minus x, between 1 and 3 inclusive, and 0 otherwise. So here's a picture. The 0 bits, don't forget that you are expected to draw those when you sketch a probability density function. And here's the, what you might say, the interesting part. So that's your probability density function. To get the cumulative probability function, we need to integrate. So let's look at that. If we're going to integrate, we get that big F of x is equal to the integral of little f of x dx, which is the integral of 3/4 x minus 1, 3 minus x dx. Okay, now we just do a little bit of easy calculus. I like to take the 3/4 out, and multiplying in, we get minus 3 minus 3 plus 3x plus x is plus 4x and the x squared term is x times minus x is minus x squared. Okay, we just integrate that. That will give us 3 over 4, 3x minus 3x plus 2x squared minus x cubed over 3 plus c. Let's just make that 3 look a little bit more promising. Well, not much more, but it's there. If I now multiply the 3/4 in, I get minus 9x over 4 plus 3x squared over 2 minus x cubed times 3/4 is over 4 plus c. And so the problem now is to find the value of c. Remember that big F of x is the cumulative probability. The probability that we are less than or equal to 1, well, 1 is the smallest value of x. The probability that we are less than or equal to 1 must be 0. That is what is going to help us. X equals 1 is the smallest value of x. Let's make that nicer again. That tells us that f of 1 is the probability that we're less than or equal to the smallest value we can't be. F of 1 is 0. Put x equal to 1, you get minus 9 over 4 plus 3 over 2 minus 1 over 4 plus c, and a little equals 0. And a little bit of arithmetic gives us that c is equal to 1. We could have said, this, you will need this idea in another one, we could have said that 3 is the largest possible value of x. 3 is the largest value. If 3 is the largest value, the probability that you are less than or equal to 3 is 1. We could have said that x equals 3 is the largest value of x, which would give us that f of 3, that's capital F, is 1. If we do that, we get f of 3 is minus 9 times 3, that's minus 27 over 4, plus 3 times 3 squared is plus 27 over 2, 3 cubed is 27 over 4, plus c equals 1. That last bit there doesn't look like a very good 4. You should be able to see without your calculator that if I subtract 27 over 4 and 27 over 4 from 27 over 2, I get nothing. So c is 1. Same value, fortunately, but we will need that idea later. So we can go on to write down what big F of x is. Remember that little f of x is defined between 1 and 3 and 0 outside. Not quite the same with big F of x. Big F of x is going to be 0 when x is less than 1. Big F of x is going to be the expression that we have up here. Just lost it, there we are. Minus 9x over 4 plus 3x squared over 2 minus x cubed over 4 plus c, which we have found is 1. And that is when 1 is less than or equal to x, less than or equal to 3. And when we're bigger than 3, when we are bigger than the largest value, the probability that we are smaller than that number must be 1. So there is your full definition of your probability density function. It will always be 0 up to the first value of x. Then you have some expression that you have to find by integrating, and it will always be 1 above the largest value of x. Please note that the book has 2 methods, 1 and 2. I don't like method 1. It works perfectly well in the small case, in the easy cases, the simple cases. I think that method 2 has significant advantages when we get to harder probability density functions. So please, if you read the book, ignore method 1. Just use the method here, which is the one where you find C and your arbitrary constant of integration. There are 2 more complicated examples coming up in the next video.